Hello everyone and welcome to AGACAD's webinar Framing with CLT Panels in Revit. Before I start, I want to make sure that everyone can hear me and can see my screen, so please raise your hands. You can do that in the GoToWebinar dialog on the right side of your monitor. Thank you for raising your hands. As I understand, you can hear me and can see my screen. If you will have any questions during the webinar, feel free to write them under questions. And now I can introduce myself. My name is Eve, and I'm an architect and a BIM consultant at AGACAD. We create applications for Autodesk Revit based on the needs of world's leading BIM practitioners. We eliminate tasks that do not create value. We have developed the widest range of true BIM software in the world for Revit's professionals, covering wood and metal framing, precast concrete design, and MEP system design. Today I'm going to talk about our BIM solutions called Wood Framing CLT. It's for creating cross-laminated timber floor, roof, and wall panels of any shape or complexity. Connectors, cuts, and supports, as well as other details, can be distributed based on predefined rules or connection types. Functions are versatile, parameters are easy to control and modify. Also, the software generates views with automatic dimensions for panels or segments, as well as accurate bills of materials and shop drawings. In this webinar, you'll see how to use predefined configurations to create CLT panels for walls, floors, and roofs. Use smart and complex connections for assembling of panels and details management, save time with identical procedures that have to be repeated, and automate shop drawings and cut lists. As a result, you'll see a CLT project with connections for walls, floors, and roofs created, cuts and supports distributed, as well as shop drawings will be auto-generated with tags and dimensions inserted just the way you want. Okay, so I already have a Revit project opened, and right here you can see that in the first level, the panels are already created using our wood framing CLT software, whereas in the second level, they are not created yet, so I'm going to do that during this demonstration. Before I start, I'd just like to quickly mention that all our tools work inside Revit, so you have to have the model already created beforehand, and it should be created out of basic Revit's walls, floors, and roofs with openings added. The software will identify all of the connections, and also all of these configurations that I'm going to show you today are sample configurations, but of course they can be modified according to your own needs. So for example, now if I would go to the framing configuration, you can just see in which window they're all created. So once the configuration is created, everything is very fast. Anytime you can duplicate it, modify it, and if it's saved on a shared location in your company, all of your colleagues can use it. So it needs to be created only one time. And here you can predefine everything from spacing of the splits to connections and opening framing. So right now I already have prepared a couple of sample configurations, and these walls will be split with the connection boards. So right now, once the configurations are already created and they are mapped to this wall type, I can just select the walls, click on Frame Wall, and that's it. The tool will distribute all of the structural connection elements, and also the panels will be split. Okay, and that's it. So you can see that the panels were split for all 4 selected exterior walls. And the connection boards are added. So we can take a look up close. You can see that the connection boards were added, the panels were split, and also I used a division profile from Revit. So I have this notch created. And you can also see that I've used different configurations for framing openings. So for the smallest openings, I chose not to split panels near the openings. Then for the larger one, I created a panel, a header panel, only above the window. And then for the larger openings, I created a panel below the opening and above the opening. So you can create these different rules based on the size of your openings in the configuration. And now also, in the same manner, I can just select the interior walls and also frame them. And you can see also the same thing right here. And now the only thing that is missing here are connections for the T and for the L joints. So I'm going to use Smart Connections to distribute those. And I will use a window to select them. Select Elements window. So I can just use Select Parts by layer in Level, and you can see they're all selected. So now the connection configuration is automatically mapped to these parts already because I predefined it in the framing configuration. So I can just use one button, Auto Insert, and that's it. The software will automatically find all of the L and T connections, and it will distribute the structural connection elements, so dovetails, to all of the selected L and T connections, as you can see. So right here, I have a dovetail added to all of the L connections and T connections as well. And now I can do the same for the interior walls. Again, auto insert. It will find the T connections with the exterior walls, also between the interior walls, and it distributed those dovetails. I can also, for example, isolate this element. So you could see that the cuts were made, so all panels are very accurate and can be exported to the CNC machines. Okay, now I will reset it, and now we can move on to the floors. So again, the same building. I have my first level floor right here, and I created a sample configuration, a different configuration for the first level and for the second level. So in the first one, I will again frame the floor just like I did with the walls. Now it will distribute, I believe, the connection boards. Yes, that's right. So this configuration is very similar to the configuration for these walls. It's a floor with a connection boards. Again, the panels are split and a division profile is added. Okay. And now I can go to the second level. And this time I will split the floor panels differently. They will not have a connection board or anything like that. It will be just a simple split because I'd like to distribute dovetails to connect them. So you can see that I don't have anything special going on. I just added a gap. So now I can select the floor parts, insert the dovetails. So I'll choose the floor part group, floor dovetails, insert, and that's it. You will see that dovetail connections will be distributed between these panels. And that's it. You can see that they're distributed. So I can turn on Show Parts, and we will see them better. So these are the dovetails, and they create cuts with certain tolerance in my floor parts. I can also isolate this element, so you could see that all the cuts were made. And of course, if the panels are too long, we can anytime split them horizontally in any location. We can even choose, let's see, this wall and split the panels based on some kind of a support element. Then I have another example right here where I will split the walls using a different type of connection, a half-lap connection, and also I will show you how multi-framing works because we don't have to frame every single wall if they are identical ones one by one. We can copy the frames automatically, and that is much faster than framing one by one. So first of all, I will select all of these walls, click on frame wall, and that's it. The tool will distribute all of the cuts for the CLT panels. Yeah, that's it. You can see that the panels are created. So these ones are created with an L connection, with a half-lap connection. And in the L connections and the T connections, I extended the parts so that later I could create these special connection cuts with Smart Connections tool. So also I will frame the interior walls, and you will see that in the T connections, panels will extend as well. Okay, and that's it. The panels were split, and again, I'm using different rules for all different sizes of openings. And now I want to show another thing, that anytime we can update the project. So for example, if the architectural model changes, let's say the opening is moved or another opening is added or anything like that, and the panels are no longer correct, anytime we can use update frame, and that's it. All of the elements will be updated based on the changes made in your architectural model. Here you can see that it was updated and it's correct again. And also we can make modifications to all of these instances. Let's say if you'd like to change a configuration for this opening and maybe you also need splits for it. Then of course you would change the configuration if you want the modification to happen in all of these openings that are the same size in the project. But sometimes we want to make a change only in a particular place, maybe only for this opening, or add another split only in a certain location. So we can also do that automatically. So let's say I will use modify opening, and I will use a completely different configuration for this one. So I can change just a very small thing, or I can change the whole configuration. And you will see that now I will have a panel below this opening. Yeah, like this. And that is when the multi-framing functionality becomes very useful. Because imagine if you would need to make the same modification for all of these identical walls. You would lose a lot of time, but with multi-framing, you can anytime copy the frames to all identical walls. So I can use multi-framing and copy and update frames in identical walls. I can select an element from this wall, and you will see that the tool will copy this frame with the modification for this opening that I made. And it's a lot faster than framing the walls one by one. And also anytime I can modify one of these walls again, and if I need to copy the change to all of the walls, I can anytime do that. Yeah, like this, you can see that the panels are created for all of these walls, and the modification was copied as well. And of course, we can do the same for all of the walls and floors and roofs in the project. Yeah, so I accidentally clicked on frame. I just need to copy and update. Okay, and that's it. The walls are copied like this, and now I can also frame the floor. So I can select the floor, and I also have a half lap configuration created for this floor. So I can just use frame floor, and again, all of the floors in this building are identical in my case, so I can use multi-framing, then copy and update frames in identical floors, and it's much faster than framing them one by one. Yeah, that's it. And as I mentioned, in any kind of location, we can split the panels horizontally if we need smaller panels, or change the span direction, anything like that. Okay, so now again, the only thing that is left here is to create the connections. So I will use functionality from Select Elements window. I will select all of these parts in the level, and they already have a configuration, so all I have to do is auto insert the connections. Yeah, so one more thing, I will do the same for these interior walls. Okay, so you can see that the cuts are here. So this is a connection for a T connection. These elements, structural connection elements for cuts, were distributed using Smart Connections automatically. It found all of the intersections T and L and distributed them. So this is the L connection now. And let's take a look at this longer wall that I had. So you can see that the T connection is created, and also the same thing for the L connections. So I can quickly isolate these elements. So you could see that the L connection and the T connection were created. Okay, so you can see that once we have the configuration, everything is really fast. Now let's take a look at another situation. So again, I will frame this wall using the configuration with the boards, but this time also I will distribute connections for the electrical fixtures. Yeah, so again, the panels with the connection board. And now I can use insert elements where I have electrical fixtures and insert the cuts for them, like this. And of course, they can be modified. All of these elements are sample ones. They're parametric. You can very easily modify the parameter values. Okay, and now another thing. I can also select all of these parts and insert the angles. So all of those angles will follow the wall length. They will not restart, as you can see, from each panel. They are following a continuous spacing. Okay, and now let's take a look at floors with openings. So again, very quickly, I will frame these two floors with the openings, and the panels will be created with a half lap connection. So you can see that they work perfectly with the openings. And also we can modify them. For example, in this case, if I want to modify a part above this opening, I can very easily do that. I can just use modify opening, select any element from the frame, and let's say that I will add a split in below and above the opening, and also a top cripple trimmer. Yes, and now you will see the modification. So the part above the opening was modified, and now I have the situation. So you can see that the tool is really flexible, and even after creating the panels based on the configuration, you can still modify some instances if you need to. And here is another situation where I need half-lap connections, not only between panels that are in the same floor, but also between panels that are in a different floor and maybe even have a different span direction, as you can see here. So I need to create a lap join right here. And first of all, what I need to do is I need to modify the paneling, and I need to extend the part. So that it would be faster, I will extend only one. And you can see now that the parts are extending. So for these parts, I already have a configuration mapped, so I can use auto insert, and it just inserted all of these connection elements to the ends of the panels. And you can see that now right here they have a lap join. You don't have to enter them everywhere. You can choose the sides on which you want to add. For example, maybe on the right side I don't need to add them, so I don't have to do that. But if we do, let's say, then we can take a look how we can do that. We can insert the elements, choose the floor part group, and I would like to add the cut on the right side. And that's it. It's added. And definitely I need it right here, so I'll need to add it on the left side. Insert. And it's added on the left, but we cannot see anything yet because I have to add a cut on the top on these panels. So again, I will use insert elements, and I will add the cuts on top in this situation. Yeah, and that's it. The cuts are added on top here, and you can see that now they are connecting perfectly. The half lap was created between two floors with different span directions. I can even isolate these elements, so you could see that this is the cut on the bottom, and they are connecting perfectly. Okay, and now another situation where the floor is already split, but I want to show you that we can also use external elements that are in our model, like for example beams, to cut the panels automatically. And also the cut can be added with a certain tolerance. Right now the cut is added with the smart connections. Yeah, so you can see that it's a cut connection, and it creates these special cuts for the CLT floor panels, and it even cuts out the floor part. I can also turn on a section view, so you can see here that everything is created automatically with the software. Okay, and now I have the roof boards. So for this situation, I will take the Roof Plus tool. And again, all of the configurations are already mapped. As you can see, all of these tools are very similar, so I can just frame the roof and structural framing elements. These connection boards will be distributed, and then I'll just have to split the parts for the CLT panels. And that's it. They are created, and you can see that all of the shapes are created correctly. I can, of course, align it. So I will show you in this roof that we can align the layout. We can modify it before splitting the panels. So first of all, I will frame this roof, and you can see that this one is with a half lap. So I will frame this roof. Okay, it's framed, but I will turn on the original for this. So you could see where the future splits will be. I can just open Align Elements, and I can simply align both of these layouts. And only then I can split the CLT panels. Yeah, that's it. So now I can go back to the view with the parts, use split parts, and you'll see that they are aligned. Okay, and now let's take a look at the roof ridge. So we can also add structural framing elements to create connections for the roof ridge, or the floor in the roof connection, or even the wall in the roof, but I will show you that later. So in this case, I can just, again, frame this roof, and you will see that this time a ridge element will be added and a connection element for the floor. Yeah, and you can see that they're here. So now I can simply cut the floor with this element, and now not only the panels, but also the floor will have a cut. So I will split parts for this roof, and now let's isolate, let's say, one part and this floor. Isolate the element. Yeah, so you can see that all of the cuts are created in the floor panel and in the roof panel and in the floor. We can also create a roof ridge that is non-metered, like this. So it all depends on your needs. And we can create various wall and roof connections. So I mapped two different configurations for these walls, and let's take a look what the results will be. So you cannot really see right now, but it added structural framing elements in the connection with the wall and with the roof. You can see here that I have this kind of element aligned to the exterior side of the wall, and on this side I have this kind of element added to the center of the wall. So all I have to do now is I have to cut this element from the roof like this, and that's it. You can see that right now the profiles of the walls were changed like this, and of course the cut was also made in the roof. And these families, as we mentioned, they can be modified. You can create your own profiles or just modify the parameter values that are in these families. Okay, and now I think I'm done with the modeling part, and now I'd like to show you the shop drawings. So in the beginning, we created this model with T connections, L connections, and so on. So let's create a few shop drawings of these panels. So first of all, we should number the walls. Yeah, we should number, and the same thing goes for the floors and the roofs, obviously. So we should number the walls, and the tool automatically writes in the mark parameter value into the walls. So you can, of course, modify the rules, how it's numbering the elements. For example, in my case, the walls are numbered based on the level in which they're in. Let's see, level number 4, exterior wall number 2. This is level number 2, exterior wall number 10. And let's try to select interior wall. This one is level number 5, interior wall number 5. And now, also before numbering the parts and other elements, I have to enter a couple of values to the parts manually. I don't have to, but if I need to, I can do that. Let's say that we will create shop drawings for this part that is in the L connection, and for this part that is in the T connection. They're more interesting, I think. So let's try to do it for these. So the first thing that we have to do is we have to enter a building number. Let's say if you have more buildings in your project, you can enter a unit number. So let's say this will be B number 1, let's say. Okay, so I just added it for all of the parts in this building. Okay, so now all of them have this parameter value. Now I can also enter visual interior and exterior quality. So for this part, let's say I will enter interior V. You can enter anything here, it's just a text. So it depends on your standards. And for this part, I will add something different so we could see the different result. Let's say like this. Okay. And then for this part, the part level will be calculated for all of them automatically. I will turn on the grain direction parameter value. And for this one, I will turn it off, and you will see the difference in the tag. So one of these will be horizontal grain direction, and another one will be vertical. And based on that, the tag will automatically rotate on the shop drawings. Okay, and now when I added these values, I can number the parts, and this part level parameter value will be filled in automatically, as well as a lot of these parameters. You can see they're empty, but they will be filled in automatically. So that's all that I had to do manually if I need this information. Okay, so finally I can number the parts, and it numbers all of the parts in the project, not only these two. Okay, and you can see that part level was entered automatically, so it's based on the level and on the identity number, on the ID, elements ID. So it's in the level number 5, 22, again, number 5, 21, number 5, 37, and so on. Number 2, 07. Okay, and then finally we can number the elements. Okay, and again, you can see, I forgot to show you all of the other ones. Let's see, the mark of the part is also filled in automatically. It's created from the unit number, as you can see, and the part level. These two parameters combined, you can of course change that. And the part can see its host member sort mark, so it knows in which wall it's located, in the exterior wall number 2 and the level 5. And for the shop drawings, we also have a special tag family. So I will select these two parts, insert elements, and you will see that in this detail we will see the interior quality even in the 3D view. So you can see that I have these tags right now, and it writes me the exterior and interior visual quality. So you can see that what I wrote in here, that information appears in this 3D tag. And of course, you can hide it in the 3D view if you don't need it. But if you want it, you can also keep it. It will be visible in the shop drawings. Okay, and now the last thing is the shop drawings with smart assemblies. So I'll open another tool and create assembly for this part. And you don't have to create assemblies for each part individually. You can just select a lot of them and create them. But I want to show you one thing. So I'll just create one and only then another one. So now let's take a look what was created automatically with the software. So this assembly was created, and all of these views and schedules were predefined in the shop drawing configuration. So you can see here the panel in the L connection. I can see the exterior quality value, visual quality, and right here we have the top view where again we can see the visual quality in the interior and exterior side. Also, the dimensions are added automatically. You can modify the rules, how they're added. And I have the schedule with this wall panel, its length, thickness, and height. And then here is the front view. So you can see that for this part, I kept the tick mark on. And that means that the green direction is horizontal. So that's why this tag is horizontal. The arrows show the horizontal green direction. And on top of the tag, you can see the mark parameter of the part, B1522. And on the bottom, you can see the exterior visual quality and then the interior visual quality, the one that is behind. And again, all of the dimensions are added automatically. And we also have a left view. So now finally, I can add a 3D view. Let's see here. Then I can add the front view here, the top view, then let's say the left view, and the schedule. And you can create as many schedules or sheets as you need. I just created only one for this example. And now I will go to the shop drawing configuration, and I will see that I want to use this sheet as a template for my future panels. So in the sheets, I will say that this sheet that I just created for this panel will be a template for the future ones. So now I could just easily select all of the panels and create assemblies for them. Okay, so I will go back to this view and I will create an assembly for this panel. Okay, that's it. It's already created. And again, in this panel, I have all of the same things. So I have the 3D view, the plan view with all of the dimensions and interior and exterior visual qualities, then the schedule, elevation front view. This time you can see that the green direction is not horizontal, it's vertical because the tick mark was off. Also, the mark is written on top. Here is the visual qualities and the left view of the panel. And this time I also have a sheet created automatically using the same layout. So remember that previously I created this sheet manually and then I set it up as a template, and this sheet is created automatically for me. Okay, so I think that's it for today's demonstration. Now I will quickly go back to the slides and just inform you that there is a paid trial for this software. So you can try it out. To access the software, you'll need sample families, sample configurations, and personal training with our engineers. And for that, we offer a paid trial that includes Revit project with sample families and configurations, then personal online training to answer all of your questions, and 30-day software trial with technical support. For more questions, you can visit our frequently asked questions page, and maybe you'll find the answer there. If not, of course, you can contact us and we will try to help you out. Okay, so then thank you everyone who attended this webinar. I hope you found out something new and I hope to see you in our future webinars.
AGACAD, building BIM together.